You click a link and boom, a web page just appears. It feels instant, almost like magic, right? But it's not magic at all. It's actually this incredibly powerful, invisible engine that runs our entire digital world. So today, we're going to pull back the curtain on that engine, the network server. So think about it. What is really going on in that tiny little gap between your click and the page loading? It's not just one thing. It's a lightning-fast conversation between your computer and another one, which could be thousands of miles away. Let's dig into how that conversation actually works. You see, at the very heart of the internet is this fundamental relationship, this constant digital back and forth. And to really get it, you have to understand the two main players in this conversation. You've got the client and you've got the server. Okay, let's break that down. A network server is, well, it's basically a super powerful computer, and its entire job is just to serve. It holds on to all the good stuff, all the websites, the videos, the apps, and its one mission in life is to deliver that data to other computers, but only when they ask for it. This really lays out the relationship perfectly. Your device, whether it's your laptop or your phone, that's the client. It's the one making all the requests, saying, hey, can I see that webpage, or give me that video? The server, it's the provider. It's just sitting there listening for these requests, and as soon as it gets one, it finds the data and sends it right back. So the client starts the conversation, and the server responds. And really, that's the core of it. So we know who's talking, but how are they talking? It's not just random shouting into the void. It follows this very specific, really predictable pattern. It's called the request-response cycle, and it is a foundation for pretty much everything you do online. At its most basic level, it's kind of like a simple four-step dance. First, your device, the client, sends a request. Second, the server finds what you asked for. Third, the server sends a response with that data. And finally, your client gets that data and renders it so you can see it on your screen. Now that's the big picture, but for your exams, you're going to need just a little more detail. So let's look at a more technical breakdown. Okay, so this diagram from the textbook really shows us the whole journey. Let's just follow the numbers. It all kicks off with your browser, the client, sending out a request. The web server, which is always on and listening, picks it up and sends a response back. But here's the part you really need to get. That first response, that's just the start. Your client then has to make more requests for every single piece of that page, every image, all the fonts, the style sheets. And for every single one of those requests, the server has to send another response. And this is a super important point to remember. Loading one single web page is not a single transaction. Oh no, it is a whole flurry of them. The text, each individual image, that video player, every single one requires its own little request and response cycle. Your browser is having dozens, maybe even hundreds, of these tiny little conversations in the blink of an eye, all just to build the page you're looking at. Now, that whole client-server model works perfectly when it's just a one-on-one chat. But what happens when a website or an app gets massively popular? How on earth does it handle millions of conversations all at once? I mean, just imagine a huge news site during some massive global event, or a streaming service dropping the new season of a show everyone's been waiting for. A single computer, I don't care how powerful it is, would just crumble under that kind of pressure. So, how do they do it? Well, the short answer is it can't. A single machine just can't handle it. It's physically impossible. So the solution isn't to try and build one gigantic, all-powerful super server. No, the solution is to use more servers. A lot more. And this is where the server farm comes in. The idea is actually genius in its simplicity. Instead of one huge server, you get a massive collection of them, all networked together, all working in perfect unison. So to you, the user, it just looks like one incredibly fast and reliable website. But behind the scenes, it's a whole army of machines sharing the workload. And this? This is what that army looks like. Just look at it. Rows and rows and rows of machines, all linked up, all managed and coordinated to handle a mind-boggling amount of traffic. This is the real physical hardware that powers our modern internet. So what's the whole point of a server farm? Well, it's all about one thing, balancing the load. There's a central control unit that acts like a traffic cop, directing all the incoming requests to whichever server happens to be free. This stops any one machine from getting totally overwhelmed and lets the whole system handle huge spikes in traffic. But, and this is a big but, there are some serious real-world constraints.
These farms have massive physical limitations, mainly their insane power consumption and the incredible amount of heat they generate, which means they need these giant industrial-scale cooling systems just to keep from melting down.
All right, let's wrap this up and bring it all together. In this last section, we'll do a quick fire recap of the key definitions you absolutely need to know, and then we'll put that knowledge to the test with a couple of classic exam-style questions. Okay, here they are, the big three concepts. The client-server model, that's the structure. The request-response method, that's the process. And the server farm, that's the solution to scale. If you can lock in these three definitions, you are going to be in a great spot for your exams. Okay, first question up. Now, to get all 6 marks here, you'd really want to walk through that whole multi-step process we saw in the diagram. You talk about the initial request for the page, the server's first response, and then, crucially, all those follow-up requests for every little thing on the page, like the images and the scripts. And for this one, you want to focus on the why and the what stops it. The whole purpose is about speed and load balancing. And for the constraints, you've got to talk about those huge practical challenges, the need for a constant, massive supply of power, and the absolutely critical need for cooling. So the next time you click a link, just take a second and remember what's really going on. You're not just grabbing a file. You are kicking off this incredibly complex, high-speed conversation with a server, or maybe an entire farm of them. That could be halfway across the world. The entire internet is built on these conversations. So the only question left is, what are you going to ask for next?